Chapter 7, The Wonderful World of Integration Techniques, by Grace, for Grace. Here's the rundown. There are many techniques to integration, and the key way to becoming a true integration master is being able to look at an expression and determine which technique you should use to integrate that expression. Let's take a look at the different strategies that we can use on the integration problems we encounter. 1. Just integrate it using the basic integration formulas. 2. Rearrange with algebra and integrate. 3. Use substitution. 4. Integration by parts. 5. Improper integrals. 6. Integrating rational functions by partial fractions. 7. Integrating trig functions by substituting with half-angle or Pythagorean trigonomic identities. Today I will be focusing primarily on rearranging with algebra and integrating and improper integrals because they are the one that I struggled with the most, and since this video is for me, that's what we're going to look at. Take this problem for example. Find the integral of 1 minus x over x dx. Looks kind of complicated. It's one giant fraction. What do? Well, if the numerator is one expression minus another one, then you can split it up. So let's split this fraction up to the integral of 1 over x dx minus the integral of x over x dx. That's a lot easier. I know how to integrate both of them. It's pretty simple now that you look at it. Easy. Alternatively, you can rearrange the expression by long division. However, this is a little bit more complicated and I don't really like it as much. But you'll get the same answer anyway. I think that practice problem was a little too easy. Let's find one that's a little bit harder. So let's try to integrate the expression, the integral of x plus 2 over x squared plus 4 dx. Well, from all my experience, I see that the denominator looks pretty familiar. Kind of like the derivative of arctan. So I'll keep that in mind. There are actually multiple ways to approaching this problem. So in the numerator, we can see an algebraic function. There is also another function, the derivative of arctangent. Now we see two functions and we can actually integrate using integration by parts. However, integration by parts is a little bit tricky. I like making things easy. So I think I'll try splitting up the fractions first, using algebra. I split up the fraction, I get the integral of x over x squared plus 4 dx plus the integral of 2 over x squared plus 4 dx. That looks a lot simpler. So in the first expression, we can just use substitution, and then we get 1/2 ln x squared plus 4. In the second expression, we can use basic integration rules and identify that 1 over x squared plus 4 can be simplified to arctan x over 2 plus c. When you see an infinity symbol, you'll know that you'll have to rewrite the integral with a finite limit of integration and consider what happens when that endpoint approaches infinity. However, sometimes they aren't that obvious. Infinite discontinuities are a little bit harder to identify. So when you come across an integral expression, don't start integrating too fast. Inspect the denominator. Are there any vertical asymptotes? Are there any discontinuities? If the answer is yes, you're going to have to rewrite this integral too. Let's take a look at this problem. X to the negative 1/3 dx from negative 1 to 8. Well, if you rewrite this expression, it looks like this. Wait, the x is in the denominator. What does that mean? Well, there's a discontinuity at x equals 0. So what do? We have to rewrite it. We want to write the expression into two parts. The limit as a approaches 0 from the negative side, and the limit of b approaches 0 from the positive side. From there, we integrate using a and b on their respective limit expressions. Then we can plug a and b in. Then we get negative 3 over 2 plus 12 over 2, which simplifies to 9 over 2, the answer. It's a good thing we took a good look at the integral expression before we started integrating, so we knew to rewrite the expression using limits. So let's reflect. What was the moral of this video? When you see an integral, take a step back, breathe, and look before you integrate. First, ask yourself, is this an integration formula? Could I just integrate this expression in one step? If not, ask yourself, can I use algebra to make my life easier and integrate this expression? And always check for any hidden discontinuities in the problem. Only then are you allowed to continue integrating using any of the other wonderful integration techniques from Chapter 7 that we've already mastered. Grace, I hope you watch this video again, and I hope you watch it often, because this is going to make us BC masters.